So, you want to build a fusion reactor at home. Okay, first things first, do not actually try this unless your idea of fun includes glowing in the dark and explaining things to federal agencies. But hypothetically, let's take a ride through the wild world of nuclear fusion, the same process that powers the sun, and figure out how, in theory, you could turn your garage into a miniature star factory. Alright, what is fusion? Fusion is when two light atomic nuclei slam together and merge into a heavier nucleus. This releases a ton of energy. Why? Because when you fuse, say, two hydrogen atoms into helium, you lose a bit of mass, and Einstein told us that mass times the speed of light squared equals energy. Boom. Literally. Fusion is kind of like cosmic alchemy, you're turning one element into another and cashing in on the leftover energy. But why do we care? Well, it's clean energy. No carbon emissions, and it doesn't produce the nasty long-term radioactive waste that fission reactors do. Fusion is basically the holy grail of power sources. And, you know, having your own miniature sun in the basement sounds cozy. Okay, so how do we hypothetically build one? You've got a few options, but the most doable backyard fusion device is something called a fusor, specifically an inertial electrostatic confinement fusor. It sounds super fancy, but it's actually been built by high school students. Seriously. Google, teen builds nuclear fusion reactor. It's a whole genre. The core idea is, take a vacuum chamber, put two spherical metal grids inside, and inject some deuterium gas. That's hydrogen with an extra neutron. When you apply a high voltage, we're talking tens of thousands of volts, the deuterium ions accelerate toward the center, collide, and some of them fuse. Now, will this light up your house? Nope. These amateur fusers do achieve fusion, but they consume way more power than they produce. Still, you can get some real fusion reactions going, enough to detect neutrons. But wait, deuterium? High voltage? Neutron detectors? Yep. Hypothetically, you need a vacuum pump, a deuterium gas source, high voltage power supply, a sealed chamber, and something to detect those fusion byproducts. Sounds expensive and complicated? That's because it is. And potentially dangerous. Again, don't actually do this. Time to bust some myths. Myth number 1, fusion is easy, the sun does it all the time. Yeah, but the sun has gravity on its side. Like, a lot of gravity. You don't. Unless you're hiding a few million tons of hydrogen in your backyard. Myth number 2, fusion reactors explode like nuclear bombs. Nope. Fusion reactions require constant input to sustain. If something goes wrong, the reaction just stops. No mushroom clouds. Just disappointment and maybe a power outage. Myth number 3, fusion power is just around the corner. We've been 30 years away from fusion for, well, over 60 years now. It's always close, but tricky. Scientists are making real progress, though. Shout out to the folks at ITER and NIF and their billion-dollar science toys. So, what's the takeaway? Fusion is real. Fusion is amazing. And fusion is very difficult. Hypothetically, yes, you could cobble together a fusor in a garage, but turning that into something that powers your fridge, or even your toaster, is a whole different universe. Still, the fact that fusion is even kind of accessible to high schoolers and tinkerers is wild. It's a glimpse into a future where energy might be as limitless as our curiosity. So, keep dreaming, keep learning, and maybe leave the fusion reactor to the pros. Or at least to the ones with better lab coats and less flammable garages. Thanks for watching, or listening, and remember, science is awesome, but maybe keep your experiments glow-free.